So notes 13, page 9. This is another problem, a type of factoring. We haven't done one exactly like this, but we've actually learned all the techniques we need to factor something like this. So be careful, especially on the test. There will be times when I tell you to leave negative exponents. Follow instructions, just leave them. It's a lot easier to deal with this if you just leave the negative exponents. A little background on this problem. If you go to calculus, and I believe that you use the product rule, you will get something like this. And then you'll want to set it equal to 0 and solve it. To do that, you'll want to be able to factor it. So this is a skill that you might see if you wind up taking calculus. But it's a skill we actually already have. So first thing, if you see a problem like this on the test, 1, follow instructions, leave the negative exponents. 2, don't panic. What is the first step in factoring? Look for a GCF. All right, well, there is a GCF. I do have 2 terms here. 2 is part of the GCF. I'm gonna write it over here first. And then x plus 1s are common. So x plus 1 is part of the GCF, and the most it's common is twice, using the smaller exponent. And x minus 1 is a factor that's common to both. So that would be part of my GCF. Now here's where people will mess this up. The general rule when you're deciding what exponent you should use in your GCF is you use the smaller of the 2. If the factors, the factor showing up twice, use the smaller of the 2. Negative 2 is actually smaller than negative 1. So we would use negative 2 as the exponent as part of the GCF. So that's a big fat GCF. So when you factor out a GCF, you write it in front of blank parentheses. And since there are 2 terms in your original expression, there should be 2 terms here. We just ask this whole mess times what will give me this term back. And I look at it. The 2, I'm set with that. X plus 1 squared. I need an x plus 1 to the 3rd. I obviously need to multiply in 1 more x plus 1. And the x minus 1 to the negative 2nd, that's what I got. I don't need to adjust that, so that's it. It'd be x plus 1 to the 1st. Okay, then minus 2 times what will give me 4? That'd be 2. Okay. X plus 1 squared. I don't need to multiply any more x plus 1 squareds in, because x plus 1's in, because that's exactly what I wanted. X plus 1 squared. Okay, x minus 1 to the negative 2nd. I need to distribute that and wind up with x minus 1 to the negative 1st. So I'm going to have to multiply in something up here, some x minus 1s. And this is the other little tricky part, but we've done this before. Remember, when you're multiplying the same base, you add the exponents. So we're really asking negative 2 plus what exponent would give me negative 1, and that exponent is just 1. All right. Now, when you come across problems like this back factor is a mess. Simplify this factor. Clean it up. So now I'm just copying over the GCF. I need to distribute the negative 2, so it'd be negative 2x plus 2, and then I can add like terms. I'm just copying a whole lot over. This is going to be 3 minus x. I put the x in the back because it was negative. That's very typical, so you don't lose the negative. So 1 plus 2 is 3. 1x minus 2x is minus 1x. And this would be the final answer. Notice it's now all one term, and every factor is prime. Now, it's really important that you realize there are restrictions on this expression. See how, I told you to leave the negative exponents, but if you remove the negative exponents, this is a factor of the entire term, so you can send that factor to the denominator of that term. So you can rewrite this as 2 times x plus 1 quantity squared times 3 minus x all over x minus 1 quantity squared. So you can send this factor to the denominator of that term because it's all one term, and that's a factor of the term. And you realize, oh, there are restrictions because this factor is really in the denominator, so x cannot be 1. Okay? Now, on a test, I would just ask you to leave it this way. All right? But I might be sneaky and ask you for restrictions. So you just kind of just visualize that. Oh, that factor is really in the denominator, so don't let x be 1. Now I want to show you some connections here. We could have looked at this problem in another way. You know, we're trying to simplify this, and the next step would be setting it equal to 0 and solving it if you were in calculus. You could opt to remove the negative exponents first. This is the harder way to go. So this is a factor of this term, so when you remove that negative exponent, that factor goes to the denominator of that term. This is a whole nother term over here. So when I remove the negative exponent from that factor, it goes to the denominator of that term. All right. Then you'd have to get a common denominator. Well, what would the LCD be? Well, the only factors that you see in the denominators are x minus 1s, and you have to build up denominators, so you use the larger exponent. That would be the LCD. And so I would multiply this times x plus 1 over, oh, not x plus 1, what am I thinking? X minus 1 over x minus 1. Okay. All right. And then this would be minus 4. Oh goodness, I don't really want to do this. Look at this mess. See, I would need to multiply this out. This is x squared plus 2x plus 1. Then I'd have to go times x minus 1 over the LCD. And I would have to multiply this out. Don't you dare distribute the exponent to those terms. You'd have to go x plus 1 times x plus 1 times x plus 1. There's actually a pattern for the cube of a binomial. I know it, but we didn't really teach it. And it's just like, ugh. You'd have to multiply that out, multiply all that out, subtract your numerators, combine your like terms. When you get done with that, then you could try factoring it. You will get that right there. Notice what factoring out the GCF did for us. It got us a common denominator in a really sneaky way. When we factored out the GCF, we wound up condensing these two terms to one term. Then I removed the negative exponent. I essentially added these two fractions without going through all those steps. Kind of cool, kind of sneaky. All right, this next problem, I don't think I'll ever give you anything quite this big on the test. I'm sure I won't, but I'll go over it real fast. This really does happen when you use the product rule. When you take in the derivative, you get things like this that you want to factor. The GCF, here's a tricky little thing. Between 1/3 and 4, it's like, what? How's our GCF? If you make 1/3 part of the GCF, you can pull all the fractions out of all the other factors. So I'm going to do that. X plus 6 is common to both terms. So x plus 6 is part of the GCF. Negative 2/3 is smaller than positive 1/3, so I'll use it as x plus 6 to the negative 2/3. 2x minus 3 is common to both terms. And the most it's common is 1 time, so I use it that way. So I pull out this monstrous GCF. There are 2 terms here, so I write my GCF in front of one set of blank parentheses, and I'm basically asking this times what will give me that term back. This times what will give me that term back. And so if I look at the GCF and this term, all I'm missing is 2x minus 3 to the first. That's the easy one. Okay. Then I gotta go, this mess times what will give me this term back. And I have to ask myself, 1/3 times what will give me 4? 1/3 times what will give me 4? Well, I could solve that. Multiply both sides by 3. Oh, that box I'm looking for is 12. There it is. And then my GCF has x plus 6 to the negative 2/3. I need to wind up with x plus 6 to the 1/3, so I need x plus 6 to something. But then we have to remember, I'm multiplying the same base. I add the exponent, so I'm asking negative 2/3 plus what would give me positive 1/3, and that would be 3/3, which is just 1, okay? And then that's the hard part. The back factor is a mess. Notice the back factor has no fractions, and that was my intent by making 1/3 as part of my GCF. It seemed a little strange thing to do, but hey, the only fraction in this whole problem now is that 1/3 out in front. I distribute the 12, I combine my like terms, and there it is. There it is in factored form. Notice it's all one term. Notice this factor has a negative exponent, so it's really in the denominator, so you better not let x be negative 6. Okay, so not going to put anything quite like this big on your test. If this problem shows up on your test, it'd be more like this one here.